what is computer architecture, and then the studies and things involved, and what is demanded of us during the semester. So that is what we do today. So again, the course we'll be doing this semester is computer architecture. So we'll be learning computer architecture. The course involves us to, or the course allows us to learn what is the architecture of the computer and how we can build and then maximize the architecture for anything in which we want to do. For the course, I'm going to be your lecturer. My name is Mark Fiamwini-Mepsa. You would see my email address on the screen, and you would also see my phone number on the screen. That is, if you want to contact me for any reason that you need to contact me, you can, or you can send me a WhatsApp. See, and try and reply. Please do not call me after 9 o'clock. Or 9 o'clock, you leave me alone. When it is 8 o'clock in the morning upwards, you can call me and worry me or whatever you want to do. But the moment it's 9 o'clock, please just leave me alone. Okay? And that is number one. Now, the second thing is the rules of the class. It's very important that before we start a class, we both understand each other in terms of the rules in which we want to do. So the first rule of the class is that time. Not like waiting for people. My patience is very thin when I have to wait for someone. So as you can see, the link for the class was sent days ahead because I want to make sure you have the link and no one can say they didn't get the link. The second thing too is that if there would be a change in time, for example, today there was a change in time because I was stuck in traffic. I had to come to campus because I have another class on campus. So the time, so I had to come. I will let you know ahead of time that you can prepare yourself. So please, the time is the time. If it is 6, it's 6. If it's 7, it's 7. Do not be late. I do not like lateness. I do not want it. Do not be late. That's number one. Number two is there is a tendency for people to treat you like you are children. You are not children. You are adults. I will not come and beg an adult who is paying me to teach him to come to class. I will not come and beg an adult who is paying me. And note, I'm being paid to teach you. If I wasn't being paid, I will not be here. I will not even come. So as an adult who is paying me to teach you, I will not come and beg you to do assignment or come to class or do any of those things. And I will treat you like an adult. To be honest with you, I am teaching university because I cannot teach children. I do not have the patience. So please, respect is very important. Timing, respect, tone of voice, everything is very important. And again, we have class on campus, the time is the time. Do not be late. Because I would not like to wait for you or you to come in. For the semester, these are the things we'll be doing for you to get your final grade. On the screen, you can see assignment 1, assignment 2, then there will be a group project, then there will be a mid-semester, then your end of semester exam. So these are the percentages that are awarded to each group per the school rules. So make sure you note what you do in each one because each one will be tabulated towards your final score. And the final score is the final score. Before I go on, are there any questions? Anything you want to say before I go? Okay. If there are no questions, then we continue. So, as I said, the course we are going to do today is computer architecture. So the question here is, um, what is the architecture of a computer? Or when we say the architecture of a computer, what are we talking about? Computer architecture or digital computer organization is the conceptual design and fundamental operational structure of a computer system. So beside it, we have an image over there, and the image is showing us, this image here is showing us the design of the computer's architecture. Of course, we have input devices and output devices here. We have your keyboard, mouse, scanner, joystick. We have your monitor, printer, speaker, headphones, all peripheral devices over here. But we are focusing a lot on the middle part where we have the CPU, the memory. So in the CPU, we have the control unit and the ALU unit. So we are going to focus on these two units and the memory and discuss them. How do we build them? How do we control them? What mathematics goes behind them? How do we make it more efficient? How do we make it more productive? How do we improve performance? How do we get the best of our computer? And this is what the focus of our course is going to be. We would focus a lot on these areas and how we can improve, build, and what they are for the whole semester. Again, if you have a question, you can just raise your hand. And there is this thing whereby a lot of you, instead of asking a question in class, you are either afraid or shy or something. I don't even know. You pay equal fees as the friend of yours. No one is going to laugh at you in this class. No one will make fun of you in this class. The moment the class starts to the ends, we are here to just learn, close, and go home. So if you have some question which you need to ask, you can ask. Now, again, computer architecture can also be defined as the blueprint and functional description of requirements and design implementations for the various parts of the computer, focusing largely on the way by which the central processing unit performs internally and accesses addresses in memory. Again, back to the picture, we can see that our focus, as I said, would be here, where I have the CPU, the CPU, and then the memory. My focus is going to be at that section. That is where my focus would be. And we'll be looking at how the CPU works and how it uses the memory to transmit data between itself and then control that informational spread between those two things. So that is what we'll be focusing on primarily during this entire semester. We can also define computer architecture as the science and art of selecting and interconnecting hardware components to create computers that meet functional, performance, and cost goals. Again, let's look at these three statements here: functional, performance, and cost goals. Contrary to popular belief, computers are not all the same. All computers are not the same. Some computers are built for specific purposes. Or let me rephrase that. All computers are built for specific purposes, which means that, for example, if I were working in an office in which my main focus was word processing, so I'll be entering data, processing the data, printing, and all of those things, I do not require a computer whose job will be to analyze weather patterns, for example, because the weather patterns needs analytical data, hence it needs more processing power, it needs more memory to do what it needs to do. For me to process things, I don't need that kind of capacity to be able to do that. I don't require that kind of capacity to be able to do that. Hence, when I'm building a computer, when I'm buying a computer, I must ask myself an important question. What am I going to use it for? And what I'm going to use it for will determine the performance in which I want to give my computer. Some of you are in this class whose computers, when you click on it now, you would have to wait till, I think maybe when Jesus Christ comes, before the computer will respond to you. Performance. When you click, how quick is it to respond to you? When you want to do the things in which you are meant to do it for, use it for, how fast will the computer react to the things in which you want to use it for? And remember, you are using it for a particular functional purpose. That means that for you in this class, the computers you buy has to have a larger memory and processing power because you'll be writing code, because you'll be analyzing data, because you'll be using it for uh, back-end IT stuff compared to, let's say, another student who would not be doing all of those things. So they can go for a lower performing computer, which is cheaper. And again, we must make sure that the amount of money you are buying for the computer is matching the performance you are getting. So it's not like you just go to the market and then go and pay 30,000 Ghana cedis for a laptop. And when you come home, you are using it to watch movies. The cost benefit of those two things do not match. You prefer to have a computer, which is expensive, meeting the needs of its expense. And these are things we'll be looking at during the lifespan of the course. Now, with that in mind, what are the components of the microcomputer? So when we say the microcomputer, what are they? What are the components that make it up? And we saw some of them at the picture in which we did at the beginning, but let's discuss them here. We have the microprocessor, which we call the CPU. We have the buses. We have the memory. We have the input and output devices. We have the parallel and serial of those input and output devices. We will look at that. We have the I/O interrupt and what the I/O interrupts are meant to do, which is very, very important in our computer. We will look at that. And then we have the direct memory access, the DME, in which we will look at that. Another very important thing as we are going along in the course is that there are a lot of abbreviations we'll be seeing. In this slide alone, we've seen CPU and we've seen the DME. Please take note of these abbreviations and write them down because very soon we will not be saying the full term. I will just be saying the abbreviation, and it will be assumed that you know what that abbreviated term means. So take a note of that as we go along. Now, these components here are designed, to look like this. So over here, I have the CPU, and the CPU would be made up of the ALU unit and the registers and the control unit. And then there will be the bus lines, the lines which transmit data between all the other devices. So you can see that the direct access memory, the main memory, the serial inputs, the programmable interrupts, and then the parallel input control are all connected to the bus lines, and the bus lines carry the data that connect to the CPU. And we can see we have the data bus, the address bus, and then the control bus. They are not the only buses which are there, but they are the main buses in which are there. So we will have to discuss the data bus, the address bus, and the control bus as we go along. Again, before I continue, are there any questions at this point? Marvelous. Then let's continue. So before we go ahead and discuss these things, looking at this diagram Looking at this diagram as we have it over here, the question in which we want to ask is that, how does this relate to um, present day world? Or how does this look like in the present day world in which we are in? How will this diagram look like? So here I have a diagram of a computer with its back open, and we are going to look at the diagram and see what we are talking about. So over here we have the RAM slots, we have the fan, we have the heat sink, we have the video cards, we have the central processing unit, we have the USBs, we have the chip, we have the offset chip, and then we have the Cosmos battery, we have the Wi-Fi card that gives you Wi-Fi, and we have the hard disk slot. Let's have a quick discussion about this. So whenever I talk about the central processing unit, that is the CPU, when we're having a discussion on that, I am referring to the processor over here, what is under the heat sink. So the processor here would be under the heat sink. It is very important that you understand that whenever you open the back of any computer, desktop, laptop, phone, nowadays the TVs are basically just computers walking around. Anything you open, wherever you see the fan or it produces a lot of heat, that portion would be the CPU, because the CPU produces a lot of heat. Another important thing to also note is that the metal here is used to collect the heat. And of course, if you have done basic physics, you know that heat on metals, they travel. So it means the heat will go upwards here to where it is cooled because of the fan. Hence, the fan blowing on this rod here keeps the CPU very cold, very cool. So it gets hot at the on top of the CPU. The heat moves it to the fan. The fan blows on it. It becomes what? Cold. Of course, the heat will always move to where it is cold. Hence, your computer will have a temperature which is very, very cold. Thus, you do not close the ports on your computer, because that is the way in which the heat is propagated outside. So whenever we mention the CPU, we are talking about the positioning of it being under the heatsink. So it is under here. That is the CPU we are talking about. Another thing in which when we talk about, oh, sorry, 1 second. Okay. So another thing that we will talk about, oh, let me just do this very well. I Okay, so another thing that we will talk about when we talk about the memory. When we say memory, we are not talking about your hard disk. That would be your secondary memory. Or we are not talking about your USB drive. Whenever I mention memory in this context of this course and going forward, I am talking about your RAM. That is, on your computer, we are talking about the things which are located in your RAM slot. So on your computer, this section here, okay, the section in which I've narrowed down and it says RAM slot, that is what we are talking about. Now, that is where primarily you put your memory card. So over here, we can see that the RAM slot here has the memory cards in them. So these memory cards are here. And again, if we're looking at this very well, the dark side that is close to the memory slot, that is this side here. This dark side here is going to be your CPU. Why is it going to CPU? Because obviously the rod, the copper rod is here to propagate the heat out. Hence, we are removing the heat from the CPU. The primary reason why you have a fan is because of the CPU. You can see that there is no fan anywhere else apart from the CPU because it is the only thing which gets hot. So it's the only thing in your computer which needs cooling down. So again, whenever we say memory, we are talking about the RAM slots in which you have over here. Again, some of you in your computers are using 4 gig or 2 gig. By the way, if you are doing this course, don't use 4 gig and 2 gig. Okay, so you must use something above that. So let's say 8 or 16, preferably 16. But that's the conversation for later. But when we say memory, we are talking about the slots in which we have here. We are not talking about your hard disk. It's very important we note that. So again, the design we have here is how every computer is designed. If you take the pictures in which we have over here, on the green thing you see here, the board, the lines, the white lines you see there are the bus lines. So they are used to transmit information through the board. So again, the look in which we have here is an architectural look of how it should be in the real world. So our focus again on this course is to design the computer in such a way that it will perform to the best of its ability for us going forward. Are there any questions at this point? Again, you are free to ask a question at any point in time in which you like. Feel free because you have paid. Anyway, the central processing unit is the first main topic we will discuss in this course. The central processing unit is the brain of the computer, and it is responsible for accepting data from input devices, processing the data into information, and transferring the information to memory and output devices. So this is the definition of what the central processing unit is. Its job is to, first of all, take data from input devices. After it takes the data, its second job is to process the data into information. After doing that, it's transferring the information into memory. And again, when we say memory, we are not talking about a hard disk. We are talking about your RAM. Are we okay? And then it's also to what? Output the devices, send the process information to output devices. Again, we can see that the central processing unit is organized into the following major sections, which are the ALU unit, which is the central, the ALU unit, the control unit, and then the registers. The register's job is to act as the private memory of the CPU. The ALU unit is used to do all computations and logical reasonings for the computer. And then the control unit is there to more like a manifest or like a captain in a ship, control and know what each part is doing so that everything would work in sync and in unity. With that in mind, let's us dive into each section. So the function of the ALU unit is to perform arithmetic operations such as addition, subtraction, division, multiplication, and also logical operations such as the AND, OR, and the logical NOT. So these are the main operations that are performed by the ALU unit. The second one is the control unit. The function of the control unit is to control input and output devices, generate control signals, to the other components of the computer, such as read and write signals and perform instruction execution. So information is moved from memory to the registers. The registers then pass the information to the ALU for the control, for the logic and arithmetic operation. So this is the structure of the control unit, and this is the job of the control unit. The ALU unit does all the computations. It does what it's supposed to do. And it doesn't do just computations. It does computations and logical reasoning using and, or, and not. Now, again, you people should have done the and, or, and not from your classes in previous classes where you do nege nege por nege, that kind of thing. So that kind of logical reasoning is what we are saying and, or, and not. So we'll have a look at that in terms of when we are doing digital arithmetic. We'll do that as part of the courses we are doing, as part of the classes we are doing. So we'll learn it over there. But for now, we need to know that it does that. But the control unit, its job is to sit on top of everything and say, okay, this is the amount of time you're supposed to spend doing the computation. When you are done, send it here. And then its job is also to note, has it been sent there? You know, do we have to move it to another section? What do we need to do? Its job is also to communicate with all the peripheral devices, the inputs and the outputs. Has it been sent? Has it been collected? And all of those things, that is the job of the control unit. Its job is to sit there and do that job and control everything which goes on. The register is a fast memory that sits within the CPU, because the CPU cannot always go to the memory. The distance alone would reduce the time in which it uses to do things. So in itself, it has its own private memory that when it is doing computations, it can save things there or hold things there for some very short time. And whenever it needs to do something else, it can just go pick it, do whatever it has to do. And if it has to now be sent to memory, finally, it can send it there, knowing that its time will not be affected in the things in which it is doing and the programs it is running. More so, inside the CPU, we have the bus lines. And again, I spoke about the bus lines being like the highway that is used to transfer information from one point to the other. Again, you are not children. So there is absolutely no reason for you to unmute if you do not have a question. So please, unless you have a question to ask, do not unmute. And the class being online doesn't mean you should sit at a place which is noisy and have the class. It means you should be at a place which is convenient to you for you to have the class and maximize your efforts. Online classes are not bad. It's just the way we treat it. So please, again, from the first point in which I said, the word respect. Anyway, back to CPU buses. CPU buses allow us to transfer data between the various devices within the microcomputer. So if I want to transfer information, for example, from the arithmetic, from the CPU to the memory, I would use the bus lines to do the transfer of the data. So the bus lines allow us and help us to do these kinds of transfer of data whilst we use our computer. So what are the bus lines? So when more than one wire carries the same type of information, it is called a bus. The most common buses inside a microcomputer are the address bus, the data bus, and then the control bus. Again, there are other types of buses because each bus has a job in which it is supposed to do. Each bus has information it's supposed to carry. So the main three here, we are learning about them because they are very well, they matter much to us because of what we are doing. But as we go along, we'll learn the other types of buses and what they do. So a memory with 3 address lines and 4 data lines would give you the structure here. And we will talk about that over here with the address bus line. So the address bus line defines the number of addressable locations in the memory IC. Again, let's take these points very clearly because as I said, in this course, there is a lot of math, there is a lot of abbreviations, there's a lot of technical understandings we are supposed to have. So I'll try my best to explain them to the best of my ability, but we need to have proper understanding of a few things. And the address bus defines the number of addressable locations in the memory IC. That is, in your memory, there is a block that is used to save your information. Again, let's come here to the slide that was preceding this one. So this slide here. Over here, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Possible locations in which I can save the information in which I have. And then we have the bus, the address bus coming to them being what? 3. That means that for me to know how many spaces I have in which I can save stuff, it means 2 to the power 3. So the 3 here is the address of the place. So if I come here, I can see that I can have an address of 00, 001 up to 111 because the address lines here are saved in binary. That is why I'm doing 2 to the power 3 because they are in base 2 and they are in binary. That means that if I have an address bus line of 3, it means that I have 8 possible locations in which I can save the information in memory. Why is it 8? Because 2 to the power 3 for the address lines would give me what? 8. That means that if I have a 32-bit computer, that means I have 2 to the power 32 possible locations in which I can save my information. That means that the address of those locations are saved as 32-bit addresses. So I have 0000000, that is 31 zeros and then 1 going down like that. So I get to what? 32 in binary. Again, over here, the address itself is 0000000010010, so on and so forth. So the address bus line carries these addresses to the computer, and it carries these addresses in threes. Because it carries these addresses in threes, it means that 2 to the power 3 giving me 8 are the possible locations in which I can read and write and save information in my computer. That means that, again, if I was using a computer that had 32 addresses, that means that in the memory, I will have a combination of 2 raised to the power 32 address locations in which I can save my information. But the address that is pointing to the place I can save my location will be saved as a 32-bit bus line. Are there any questions? The data bus is used to carry data to and from the memory. Each location can hold only 4 bits. The size of the memory IC is represented by 2 to the power 3 times M, where N is the number of address lines and M is the size of each location. Hence, in the case where I have 3 being the number of address lines and M being the size of my location, that means that the size of my memory would be 2 to the power 3 times 4, which will give me 32 bits. I think this is understandable. The size of the bus plays important factor on the CPU performance. Current CPU data buses is 32 bits or 64 bits. And a CPU with 32 bits data buses means it can read and write 32 bits of data in and from the memory. In early generations of a computer, contains 8-bit data buses, and each memory location holds 1 byte for reading 1 book, as shown in the diagram below. So again, if we have an 8-bit bus line, the book or the word book, when we use it, is referencing to the block of data that is used to save the information. So when I say book in terms of computer architecture, I'm talking about a block of data that we use to save information. The control bus is used to send, or the control bus controls signals from the control units to the the control bus carries control signals from the control units to the computer components in order to control the operation of each component. In addition, the control unit receives control signals from control components. Some of the control signals are as follows. So the control signals that it receives and sends are as follows. We have the read signal, the write signal, the interrupt signal, the bus request, and the bus grant. And then we have the I/O read and write. So these are the control signals it sends. And this is what they mean. If I say read signal, then the read line is set to high to read from memory location or input and output device. If it's a write signal, then the write line is used to write data into the memory. If it is an interrupt, then it means that we are indicating an interrupt request. Again, the interrupt is a flag. That's a bit of an IT term in which I used. Let me use another word. The best word I can use is flag, but I think I have to use another word other than flag. So a prompt. Okay, so a prompt. So for example, let's say I am doing something and something of more importance comes my way. I would need to stop what I am doing to do the thing that is of more importance. Hence, the interrupt is used to signal to me that there is something of more importance or more urgence coming my way, so I need to do that. So that is the interrupt, and there is an entire class on interrupt again that we need to learn. The bus request is used when the device is requesting to use the information, to use the computer bus. So if a particular component needs to use a if a particular component needs to use a particular computer bus, then you would make a bus request. And a bus grant is when that request is accepted for the computer component to use the computer bus line. Okay, so these are the control signals. These are why they are there. Again, an important topic in computing or computer architecture involves the CPU architecture. And in the world we live in, most computers are built on the von Neumann architecture. And there is also the Harvard architecture. So here we the von Neumann architecture, and this is how the von Neumann architecture is structured. This is how most computers are built nowadays. But the Harvard structure separates the bus line so that each activity is on a separate bus line. Okay? We'll discuss this into further when we appear here next week. Also, over here, we have the Intel microprocessor family. That is the main topic we'll be doing next week and going on forward. And for your reading assignments, you are supposed to go and read on the history of computers. You are supposed to read on early computers, what they are. So we have the Blaise Pascal devices. These were the early computing. We have the Enigma machine and all of those things. People are supposed to read on this. You people are supposed to read on the birth of the modern day computers, how they look like. You're supposed to read on transistors and then integrated circuits. When did they come about? When were they? When did they come about? When were they used? You are supposed to also go and read on the personal computer. When did the personal computer come about? You're supposed to also go and read on mobile computing and smartphones. When did they come about? When it is used? And then finally, where we are currently talking about cloud computing and artificial intelligence, what is this about? What component brought this about and how is it being used? So these are your reading assignments for before we come here the next time in which we will come for the class. Again, welcome to the class. How many weeks is the class rep here? How many weeks? It's 14 weeks, right? For the next 14 weeks, we are going to be discussing these topics and seeing how we can use these topics to improve the things we do. Time is very important. When I come and there are two people, I will start. If it is a face-to-face class, do not be late. If you are late, I may sack you. I may sack you. And if there is a reading assignment, there is a personal assignment, do it. Because when I record the marks, whatever you get, that is what I'll put there. And as I said, you are not children. I will not come and stand here and advise you come and learn, because at this stage of your life, you are living for you. If you do not understand, you need to learn and use these things to improve your future. It is not my job. So when I come here, I'll treat you like an adult. I'll give you respect. And I demand it. Very important. As I said, any notifications or anything, slide or anything, I will put them in your class page for you to have them. Again, in this course, there would be computation, there would be mathematics, there's a lot of reading we need to do, and then we will be looking at the performance of computers and how to build them structurally. Are there any questions before we close? And I must say, I'm very happy. Whenever I ask, are there any questions, and then nobody that says anything, it means you understand. That means that the day I will drop a question, I expect everybody to get everything correct too. Anyway, if there are no questions, then enjoy the rest of your day. The class has come to an end.
Thank you, sir.
You say bye.
Thank you, sir.
Okay.